So, we're going to close out this set of introduction videos with now looking at some of the basic computations of the vector, but in 3 dimensions. As a reminder, the book definition of vector is a directed line segment. But we can think of it as the vector, which could be drawn, something like this. It must have a direction and it must have a magnitude. Magnitude in terms of the picture could be thought of as the length, but velocity is sort of considered a vector, but speed would be its magnitude. There's other forces in physics where you would think of the force sometimes in direction form, and sometimes as we just need to know the quantity in terms of the length of the number. So for notations, we can have vector v, and in the component form you would just identify the x and the y and the z components. They're not coordinates. This is vector notation here. Or you could write it in terms of the more common in physics notation, v1i plus v2j, and we'll add a k component for the 3rd dimension. If you are in the physics or engineering type setting and they're primarily using the v1, v2, v3, then you can do that. You can certainly use component form all the time, and if you're in linear algebra and you want to use the vertical form I introduced at the very first video, you can do that. Choose one notation and use it always. My students are allowed to choose which one they want to use. I, as a teacher, prefer the first one. As a student, I read them both about the same. I've used them both a lot, so it doesn't really make a huge difference to me. So now, let's do an example. If we want to write vector u that goes from a starting point in space 3, 4, -2 to an ending point in space 0, 9, 0, there's formulas. You can look up a book formula for this. Vector u, from 3 to 0, the x value is decreasing by 3 units. It's a loss of 3. From 4 to 9, the y value increases by 5. From -2 to 0, the z value is increasing by 2. That's the vector u that goes from this point to this point. If you reverse the order, then you'd be reversing the plus minus signs of these components. Now the magnitude of this vector, in case you don't recognize these 2 points from previous videos, let's see, you square that, it's going to be 9, and you square that, it's going to be 25, and you square that, it's going to be 4. In case you missed that, that's the distance formula in 3 dimensions, folks. And that's going to be square root of 38. That's how long this vector is in 3 dimensions. The directions won't say to graph it in 3 dimensions unless I can find a way to hand out cool 3D graph paper. Alright, let's see here. But you might have to recognize it if I provide you the picture. So let's do this. A unit vector in the direction of u. If you recall, that means we want the direction to be exactly the same, but now we want the magnitude to be exactly 1. So basically, since this length is a little bit more than 6 units, we divide the components by a little bit more than 6. So that would be the vector u divided by its own magnitude. And when I take this vector and divide by root 38, I end up with, let's see, negative 3 over square root of 38. 5 over square root of 38. 2 over square root of 38. Those would be the components of a vector, same direction as u, but now this one has a length equal to 1. And one last little piece for this first example here. If we want a vector and we want it to be in the same direction as u, but we want it to have a magnitude equal to a specific number, let's say 15. So now think of coding for a video game of some sort of a racing thing. We're racing a vehicle. We want the speed to look like it's exactly 15. Well, first you make the magnitude equal to 1, and then you multiply by 15, and then the magnitude, or the quote-unquote speed, will be 15. So it's going to be 15 multiplied by the unit vector. So 15 multiplied by negative 3 is negative 45, divided by square root of 38, of course. 15 times 5 is 75, divided by square root of 38. 15 times 2 would be 30. It's a little bit messy to do the computation on this. Do it on the side. Bust out your calculator. You will find that the magnitude of this vector is exactly 15 units. It's kind of sweet how easy it is to write it this way. I'm going to do one more segment for sure that has a few more 3D vector examples, so stay tuned. See you shortly.